Good afternoon. So LCD 16:2 interfacing with PIC 18. Now what is the long form of LCD? LCD is liquid crystal display and it is used for displaying the status or the parameter in embedded system. So what is LCD? LCD is liquid crystal display and it is used for displaying the status or the parameters in embedded system. So the LCD 16:2. It is a 16-pin device which has 8 data pins. It has 8 data pins, that is D0 to D7, and it has 3 control pins, that is RS, RW and EN. And the remaining 5 pins are for supply and backlight for the LCD. It is a 16-pin device which has 8 data pins, that is D0 to D7, and 3 control pins. So the remaining 5 pins are for supply and backlight for the LCD. Then the control pin helps us configure the LCD in command mode or data mode, and they also help configure a read mode or write mode, and also when to read or write. So LCD 16:2 can be used in 4-bit mode or the control pin help us configure the LCD in command mode or the data mode. They also help configure read mode or write mode, and also when to read or write. Also LCD 16:2 can be used in 4-bit mode or 8-bit mode depending on the requirement of the application. So to use it, we need to send certain commands to the LCD in command mode, and once the LCD is configured according to our need, we can send the required data in the data mode. So here is a diagram of LCD 16:2. And the pins for the LCDs are given here. Ground pin, 5 volt, that is supply pin. Then contrast control registers, select read write enable. Data pins from 0 to 7, LED plus 5 volt and LED negative ground. So these are the pins of LCD 16:2 LCD. Now here is the interfacing diagram, LCD 16:2 interfacing with PIC 18F. Now programming of LCD with PIC 18. So in that, the first step is initialization of LCD. So it is very easy to initialize LCD. The power on LCD, then wait for 15 milliseconds, then power on initialization time for LCD, then send 0x38 command or initialize two lines 5 by 8 matrix 8-bit mode, then send any display on command, then send 0x06 command, that is increment cursor. So this is initialization of LCD. First is power on, then wait for 15 seconds, ms delay, it is initialization time, then send 0x38, that is initializing two lines 5 by 8 matrix 8-bit mode. Then send any display on command, that is 0x0e and 0x0c, and the last is send command, that is increment cursor for that 0x06. Then the next is command write function. So for command write function, send command to the data port, then make RS pin low, that is RS0 command register, then make RW pin low, that is W0 write operation, RW is write operation, or connect it to the ground. And then give high to low pulse at enable. So here is the program. So when we give enable pulse, the LCD latches and the data present at D0 to D7 and execute it as a command, as RS is a command register. So this is all about command write function. So first is data sent to the port, command register is selected, then high to low pulse on enable pin. So this is command write function. Then the next is data write function. Now in data write function, first send command to the data port, second make RS pin high, so RS is 1, then make RW pin low or connect it to the ground, and give high to low pulse at the enable. So when we give an enable pulse, the LCD latches and the data present on the pin D0 to D7 and display it on 5 by 8 matrix as RS is a data register. So here is the code for that. That is code for the data write function. Then the next is display string function. So it takes a string means what? Array of character, and send one character at a time to the LCD data function till the end of the string, and it is done by checking the null character at the end of the string. So here is a code for that. Now here we have to note some points that so the first point is LCD 16:2 power on delay. In the next power on delay, after LCD 16:2 power on, we cannot send command immediately to it since it needs a self initialization time of 15 milliseconds. So while programming, we need to take care of providing a sufficient power on delay, says greater than 15 milliseconds, and then send command to the LCD. Then the second thing that we remember is after providing command to execute LCD 16:2, it takes a time in microsecond. But for 0x01 command, that is for the clear display command, it takes 1.64 millisecond to execute. So after giving this command, we need to give sufficient delay which is greater than 1.63 millisecond. So these 2 points we have to remember. Now here is the program for LCD 16:2, interfacing of 16:2 LCD with PIC 18F. So first is the header file. Then port 0 pin is used for register select, port D1 pin is for the enable, and so interfacing of LCD 16:2 LCD with PIC 18F. So void LCD, it is initialization command. Now the main program is here, that is use internal oscillator with frequency, then initialize 16:2 LCD, then display string at location. Then this function, what is the LCD string? It is a display string at the location. So this function passes string to the display, then LCD string to electronic wing. So display string at the location, that is row location, and it passes string to the display. So this is the main program. Then next is the functions. Now delay function, then set port B as output port for LCD data pins, then LCD control, so port D is set as a output port. Then commands are given, different commands are given. So 0x38, it uses 2 line and initialize 5/7 matrix. Then 0x01 is a clear display screen, 0x06 is display on cursor off, and 0x06 is the increment cursor. Then next is LCD command 0x01, that is clear display again. Then next is send data to port as a command for the LCD. Then enable RS0, that is command register selected, enable 1, that is high to low pulse on enable pin. Then again send data to the LCD. Then RS1 is data register selected, enable 1, high to low pulse. So, and the last is delay function, that is this count provide delay of 1 millisecond for 8 megahertz of the frequency. Now for rolling display, we need to use these 2 commands, that is 0x1c and 1.8. 0x1c means shift entire display right, and 1.8 means shift entire display to the left. Thank you.